Okay, so this is the second in our Introduction to Calculus revision videos. Now we're looking at review set 14A, which is on page 390 of your textbooks. So we're going to work through the first couple pretty quickly. So initially Chantal is riding in a ski lift. Her height above ground level is shown on the graph. So is the ski lift increasing in height at a constant rate? And explain your answer. So we can say yes, it is increasing at a constant rate, and that's because it's a straight line graph, which means that the amount that it increases in height stays the same as the ratio to the amount it increases in the time. So it's a straight line graph. Which has constant slope. Therefore, height is increasing at constant rate or ratio to time. Because anytime we talk about rate, it means that we are relating it to time. So what is the rate at which the ski lift is increasing in height? The rate is equal to the gradient of the graph So we'll find 2 points on the graph. So if we have a look at the graph here, we can see that there's a point here, which is 250, 400. And the point here at 0, 0. So we've got 2 points there, so we can find the gradient equals y2 minus y1 over x2 minus x1. So we have, this is our y2 point, 400 minus 0 over 250 minus 0, which is 400 divided by 250. So we have a gradient of 1.6. Now when we have a look here, our height is in meters, so the y-step is in meters. The time on the bottom here is in seconds. So we can tell that our units are meters over seconds, or meters per second, which can also be written as meters second to the minus 1. Okay. Now we're going to have a look at the average rate and change from our function here, y equals fx, from point A to point B. The first thing we need to do is find the coordinates for point A and point B. So point A is at -1, -3. And point B is at point 2, 1. So remember, that's connecting these two and finding the gradient of that slope. So the gradient is equal to, again, y2 minus y1 over x2 minus x1. So y2, 1 minus 3 over 2 minus 1. So we have two negatives together make a positive, so 1 plus 3, and on the bottom, two negatives make a positive. So the gradient of that slope is 4 on 3. Now at this point we'd say, okay, that's something we might need in our reference page. So we'll go to our reference page and we're going to write in there our average rate of change between point A and point B. Average rate of change is the gradient y2 minus y1 over x2 minus x1. Okay, now let's have a look at evaluating limits. Now when we evaluate limits, we need to be able to set our value of the variable equal to the value that it's approaching. So in this case, as x approaches 1, we can't simplify or change that equation. So we just put the value of 1 into the variable x. So we have 6 times 1 minus 7, and that gives us minus 1. Now in this case, we can simplify this expression here. So we keep so it's equal to limit as h approaches 0. We can take h out of this top line. So we're left with 2h minus 1 over h. So the h's cancel out. So we're left with the expression, the limit as h approaches 0 of 2h minus 1. We can't simplify that any further. So now we set the h value here to 0. 2 times 0 is 0. We're left with minus 1. Now let's have a look at this one. Now obviously if we put the value of 4 in where the x is here, we're going to end up with a 0 on the bottom line. And we want to avoid that if possible. So we're going to try and factorize the top line in order to cancel out the bottom line. Now it's usually an indication here that whatever is on the bottom line is going to cancel out. So it's going to be a factor of what we have on the top line. Now in this case, we have a square here and a square here with the difference or a negative in between. So we have the difference of two squares law. Now that says where we have x squared minus another square number, when we factorize, we get x take the square root of this number, and then x plus the square root of that number. So put that over x minus 4. Because these two are multiplied together, we can cancel out that one. And we're left with the limit as x approaches 4 of x plus 4. We can't simplify that anymore. So we put the value of 4 in for the x, and 4 plus 4 gives us 8. Now, we might want to add this to our reference page. So have a look at our reference page here. Evaluating limits. We set the specified variable. So remember, whatever the variable is said to be approaching, we set that equal to the value it is to approach and evaluate. But remember to factorize or simplify first. So we always have to make sure that we factorize or simplify the expression first. Okay, now for our function here of fx equals 2x squared, so this is question 4, we need to show that the function of x plus h minus the function of x divided by h gives us this expression here, 4x plus 2h. So we already have the value of fx up here. So we need to know what's the value of the function of fx plus h. So we can solve that. We'll write it here. The function of x plus h is equal to 2 times x plus h squared. Now, first we need to expand out our x plus h squared. So because we know our expansion rules, we know that that's going to go to x squared plus 2xh plus h squared. And when we expand that out, we're going to get 2x squared plus 4xh plus 2h squared. So now that we have our expression for the function of fx plus h, we can put it into this expression. So we have 2x squared plus 4xh plus 2h squared, which is fx plus h, minus the function at x, which is 2x squared, divided by h. Now the first thing we do is we try and simplify that top line. So we have a look here, we've got 2x squared and we have minus 2x squared, so they're going to cancel out straight away. And we're left with 4xh plus 2h squared over h. And we see that h is now the common factor of both terms on the top line. So we can take that out, leaving us with 4x plus 2h divided by h. So our h is now cancelled out and we're left with 4x plus 2h, which is what the question asked us to prove. So now we need to evaluate the function 3 plus h minus the function of 3 over h. So this is asking us to put f or x equals 3 into the expression that we've just found. So if x equals 3, 4x plus 2h equals 12 plus 2h, because 4 times 3 is 12. Let's make that a little bit neater. Okay, so we'll write it again here. 12 plus 2h. So when h is equal to 0.1, we get 12 plus 2 times 0.1, which is equal to 12.2. When h is equal to 0.01, it's 12 plus 2 times 0.01, which is equal to 12.02. So the limit as h approaches 0, so as h is tending towards 0, this term becomes 0. The limit as h approaches 0 then is 12 plus 0, or 12. So what is the geometric interpretation of what we've just discovered there? And that is asking us about the slope. So if we had that graph, the geometric interpretation would be that at the point x equals 3, the gradient of the tangent to fx equals 2x squared would be 12.